This is 5-2 notes for geometry. I think it's Carson, right? Carson is the only one?
Yeah.
Yep. So, hi, Carson. We are going to fill in these 2 boxes and we're going to go through 5-2 notes. We are going to do both of them. We're not going to separate 5-2 into 2 days because it's fast. It's really fast. And it's easy. It's fast and easy. It's not too bad. Okay? So, centroid and orthocenter. Centroid and orthocenter. All right, here we go. Put under centroid. Here's the things that you need to write. Centroid is made from, this you already have, made from the medians, 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 okay? And we'll draw what a median is here in a second. A median.
Wait, when did you do this one?
When we did 5-1 on Friday and Thursday, and Tuesday, I guess, of last week. Okay.
I wasn't here on Tuesday.
I don't know. You should have one of these papers. If you don't, go look in the tray.
Well, did we fill
If
this
it's
out
not the
yet?
tray, yeah, we did.
You just weren't here Friday.
Yeah, Billy,
I
where
don't know.
were you?
I don't know.
I'll check.
All right, now here's what a median is. A median is from the
Ooh.
vertex to the midpoint. Okay, vertex to midpoint. So we're connecting each vertex to each midpoint. Let me get this out of the way. Here is A, here is B, here is C. Those are all my vertices. Okay, those are all my vertexes. When I'm talking about midpoint, what am I talking about? Midpoint of what?
The triangle.
Midpoint of the what? What?
The lines.
The lines, right? Okay, so let's say I'm finding the midpoint here, right? I'm connecting that dot back to where?
The centaur.
Probably,
The angle.
which angle?
See.
Probably C. Yep. There's my vertex to midpoint. That's my first median.
Find the middle.
You're finding the midpoint, and then you're going to the opposite side. Okay, now, what do I need to do to make sure that we know that that's the midpoint?
Put the dashes.
Put the little dash. So that tells me that that is the midpoint. Now, is this splitting the angle in half?
Yeah. No, I don't know.
Not necessarily. If it was an equilateral triangle, it would, or isosceles, but it is not splitting that angle in half. So it's just splitting the the side in half. Okay, I'm gonna do that. Say the same thing for all of the sides. So I'm gonna do
Made from the medians?
made from medians. These lines that we're drawing are all called medians. The vertex to the midpoint is the median. Okay, I'm gonna put 2 tick marks here. What'd you say?
Are they supposed to meet?
They are supposed to meet. Oh no. Yep, they should kind of meet. Oh boy.
Not the middle at all.
Okay, they should kind of meet. Mine aren't too bad. Okay, 3 tick marks on the bottom side. As per usual, Tate did a fantastic job. Okay. All right, those lines are called medians, and this guy right here, this dot in the middle where they all meet, hopefully they all meet, is called the centroid. Centroid. And the centroid, the way that I think about it is, if you want to put a little bullet point here, it is kind of like the center of gravity. Okay, the centroid is the center of gravity. So we know that like this triangle's kind of skewed a little bit to the right side, right? That dot that's in the center, that centroid, is kind of pushed to the right side to accommodate that, okay? To kind of shift that center of gravity a little bit, okay? So that's where your centroid is. All right, now, important things. A centroid does not have any congruent parts, okay? So I'm going to cross out congruent parts, but it does have something very, very particular about it that's kind of exciting, okay? This is not the same as this and not the same as that. Like those lengths aren't the same. And same thing with this. This is not the same length as that, and it's not the same length as that. None of those lengths are the same. But here's what happens. Are you ready? This is the important part, okay? Each one of these medians, like this guy right here, the big section is double what the small section is. So if this small section right here is 3, what's this section right here? 6.
That's crazy.
Yes.
You're lying.
I'm not lying.
That's not real.
Okay, let's say this guy is 10 right here. What's this one? 5, right? Yes? Okay, so the big chunk is double what the other chunk is. Now, let's say we have this thing is 12. What are the 2 chunks?
6 and 6.
Wait, what?
The whole
what
thing is
that
12.
Gravity?
The whole thing is 12.
Oh, 4.
Oh, yeah.
Okay, Now, one way to look at this is if this guy is double, if this one is double what the other one is, right? We kind of have it separated into thirds. So like this is a third, then we have a third, and then we have another third. This is double what this one is, right? But what's 12 divided by 3?
4.
4. So the small chunk is 4, and then the big chunk is double that. Does 4 plus 8 make 12? So it's like a third and 2/3, right? Okay, so down here in the bottom, I'm going to put a 1/3, comma, 2/3 relationship.
It's center of gravity, right?
Yes. A 1/3, 2/3 relationship. So we have like the 8 would be the 2/3 side, the 4 would be the 1/3 side. I'm going to say or the big chunk, CHUNK, equals 2 times the small chunk. If you need to write it out in like really, really dumbed down terms, which sometimes is helpful, the big chunk is double what the small chunk is, or the small chunk is half of the big chunk, right? Okay, in order to make it thirds all the way across, all right? So that's kind of how that works. Got it? And they're going to ask us questions like that on the homework and things like that, okay? Let's go over to what an orthocenter is, all right? This is the last one. And this one we create, I'm going to say created, from the altitudes. That is altitudes. You've heard that word before when it comes to like airplanes and such, probably.
I guess.
So I'm going to do A, and I'm going to do B, and I'm going to do C. Okay, just like we've been doing. And I'm going to pretend that B is an airplane for right now. And if I'm in that airplane and they say your altitude is blah, 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 right? They're not measuring from here down this way, right?
Straight down.
They're measuring straight down at a 90-degree angle with the ground, right? Straight down at a 90-degree angle with the ground. Now, is it splitting that bottom half or bottom side in half?
No.
No, obviously not, right? Okay, but we're going to do that for each one. So if you need to turn your paper to make it straight down, or use your note card, like if I'm going from C and I'm trying to do straight down, what I'm going to do is I'm going to place my note card like here, probably, and line him up to make sure that this is a 90-degree angle right here. Okay?
Wow.
So C, straight down, and he should come, and like this one's kind of hard to get them all three matched up. But like you got to make sure that you're at a perfect 90-degree angle. I don't know if I'm doing this right.
Me neither.
Sure, right there.
Mine was pretty good.
Yeah, there you go. There's that thing is called the orthocenter. That's called the orthocenter. Okay,
Mine was spot on.
all right.
Oh wow, that's the first time. All my other ones look crazy.
Hey, there you go.
The circumcenter and the incenter
Are all like really not in the right spot.
The
Okay.
circle is like huge, and then for the centroid it's like a small one, and then orthocenter is like
Yeah.
spot on.
Yeah. All right, orthocenter. For orthocenter, when it talks about congruent parts, the orthocenter has nothing special about him. So why do we draw it? So you know what an altitude is. Okay? All right. It's good to know what an altitude is because we do talk about perpendiculars a lot in geometry. We've done those already. We talked about altitudes. So just so that we know what altitudes are, they go ahead and do it for a triangle and they make all three of them meet. And they have a special name for it, but it doesn't have any special qualities like the other three did. Does that make sense? Okay. Go to the back side. Let's fill in these two little boxes right here. Okay. Centroid. Okay, we've got midpoint to vertex. Okay. Centroid is midpoint to vertex. What are those things called? What are these lines called again? For a centroid, vertex to midpoint. Vertex to midpoint. What were those called? The median. Median is like middle, right? And middle is midpoint. Medians. Created by the medians. Okay, we're taking the medians, those three medians, meeting them in the middle. Vertex to midpoint. It's like the center of gravity. The centroid is the center of gravity. Okay? Important facts. A blank centroid is created by a blank connected to the blank of the opposite side.
Vertex
A vertex.
to the midpoint.
Vertex connected to the midpoint of the opposite side. Does that work? We're connecting the vertex to the midpoint of the opposite side. Vertex to midpoint, that's what a median is vertex to midpoint, okay? I'm going to put in here 1/3, 2/3 relationship. Or in other words, the big one is twice the size of the small one. You know what I'm talking about? Like where it separates, okay? The big chunk is double what the other chunk is. Okay? For orthocenter, the last one, it's created by the what? Altitudes. 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 Okay? Important facts.
Does nothing.
And blank.
No.
An altitude.
Orthocenter.
I'm just kidding.
An orthocenter is created by a vertex connected to the opposite side so that it is blank to that side. 90 degrees or perpendicular. We want it to be perpendicular to the opposite side. Okay? All right, let's go to the notes. Let's answer some questions. I'll tell you which problems to do. Here we go. All right, 5.2 at the top talks about what a median is, all right? Real quick, let me discuss eventually we're going to take a test over this chapter, and here's what will happen, okay? We're in 5.2. We still have like 4 sections left before, I think there's 6 sections in this chapter. We still have a bunch of sections left. On the test, here's one thing that I will make you do. Are you ready for this? Okay? You don't have to draw these, but this is what I will give to you on the test, okay? I will say, here's a triangle. Here's a triangle. Here's a triangle. Here's a triangle. I'll give you 4 of them. And in the first one, I say, draw me a perpendicular bisector. Okay? Perpendicular bisector. That means I'm splitting the side in half. So I'm going to go here, and I'm going to make a straight line. That's a perpendicular bisector. You just have to draw one. You don't have to draw all of them, and you don't have to tell me that that's a circumcenter. You just have to draw one. Okay? Then we do angle bisector. Okay? So I'll say, here's a triangle. Draw me an angle bisector. Okay? You have to bisect the angle. You get to pick which angle you do, so I don't care which one you do. I'm going to separate this one, but make sure that when you do it, you do your little markings, okay? So you have to do that. That's an angle bisector, okay? The next one that we did was a median, okay? Median is the vertex to the midpoint, so vertex to the middle, I'm going to say is about right there, and you have to make your markings so that I know that that's the middle. So you have to draw one median, not all 3. You don't have to draw and label the centroid. You just have to draw one median. And then the last one was an altitude. Okay, so on the test, I'll give you a triangle, and I'll say, draw me an altitude, and you'll start there, and you'll go straight down. You could do it for any of the angles. I don't care which angle you use, but just draw me one altitude, one median, one perpendicular bisector, one angle bisector. So you have 4 triangles, and you'll just have to draw one of each of those, okay? We'll practice that before you take the test, but... So that's what's coming, right? I just want you to be able to tell me, like, this is what it is, this is what it looks like, right? Okay, that's not too bad. So in 5.2, they talk about a median. It's vertex to midpoint. Okay, midpoint. This is the vertex. Okay, how do I know that that's the midpoint, by the way? Because it has the little dashy dashes. It has the little tick marks, right? Okay, so that's how I know it's a midpoint. So you need to make sure you label this when you're drawing them. Okay, but that's my vertex to midpoint. Okay, now we know from the centroid theorem that whatever median I have, where this is like the chunk, that it's separated into thirds. So like here's a third, here's a third, here's a third, right? Or in other words, this guy is 2 times what this guy is, right? Okay, so that's how that works. Now they're going to ask us some questions. So they say that from B to E is 9. They want to know what BQ is, which is this chunk, and they want to know what QE is, that chunk. So I need 2 things added together to make 9, but one has to be double the other one. What? 6 and 3, right? Okay. Now, you could have done that by 9 divided by 3. If we divide that into thirds is 3. So my small chunk has to be 3, and my big chunk has to be double that, right? So 3 and 6. So BQ is 6, and QE is 3. You may come out with decimals on this on your homework assignment. I'm just going to forewarn you that. Okay, then you might have like some 0.5s and stuff. It won't get anything uglier than 0.5s, I don't think. Okay, this one, they're saying PT. This little chunk right here is 2. They want you to find KP.
4.
That is 4. Not hard, right? 2 and 4. It's like one's double the other one, right? All right, now they're going to have us graph some stuff here. So this is where it gets just a little bit tricky. I don't know about this lady. She's got like a death wish or something. She's balancing these triangular discs. It's not a disc, it's a triangular piece of glass on these things. And when you're doing that, you want to find the center of gravity, right? To put the poles. And center of gravity is like finding the centroid we talked about, right? So we're doing the centroid. And I just like feel like I would not want to go watch the show because one of those goes spinning off. It's gonna like slice me in the neck or something. I don't know. I would just not feel comfortable with this. But anyway, she's spinning these triangular things, and we want to find the centroid or the center of gravity. Okay, it gives me coordinate points. We're gonna graph these guys. 1, 10 is the first one. 5, 0, 9, 5. Those are my 3 spots, and we're gonna graph them. And then we're gonna find the centroid or the center of gravity.
Center of gravity.
Mm-hmm.
This looks like some.
I messed up.
Okay. So we're finding the center of gravity. We're finding the centroid. Okay. All right. And when we do that, we're going vertex to midpoint. Okay. Now, I do not have to do all 3 of them in order to find the centroid, which is the beautiful part about centroid. I'm going to pick one, and I'm going to find the midpoint, and I'm going to connect it back to the vertex, and we're gonna like count and do all those things. Okay. So what I'm going to do is I could pick any midpoint, but I'm going to choose this one. I'm going to choose like the midpoint of this side right here. I'm going to find the middle of that side. Okay? I'll show you. Because it comes out really nice. I'm going to show you. Okay? So we're going to choose these 2 vertices. This one is at 1, 10, and this guy is at 5, 0. How do you find the midpoint? Finding the midpoint is like finding that.
3 by looking at 5.
Formula, I mean.
What? Using what?
3, 5.
The midpoint form. What is the midpoint formula? Finding the midpoint is like finding the
Distance.
average. Finding the average. So I'm averaging them together, right? Averaging, right? Midpoint is like average. So I'm averaging 1 and 5. If I average 1 and 5 together, I add them together and divide by 2. 1 plus 5 divided by 2 is 3. Okay, then I average 10 and 0. 10 plus 0 divided by 2 is 5.
I
I have 3, 5, which is that dot exactly, which happens to be a horizontal line from the vertex, which is very, very good. Right?
How can be.
That is so whack. How long is that purple line? How long is that median?
1, 2,
This whole thing.
4, 5, 6.
6. Okay, so my 2 chunks have to be what? 2 and 4. Okay, so now I just have to decide, right? I don't have to draw all 3 of them to figure out where my centroid is, right? I have to decide, is this 2 and this 4? Or is this 4 and this 2? Like, is my centroid going to be here? Or is my centroid going to be there? Which one?
The first
That
one.
one.
The left one? Which one's going to be the center of gravity?
Definitely the left one, yeah.
Definitely the left one. I would say right here, where this is 2 and this is 4, yeah? Because we know the whole thing has to be 6. I don't have to draw all the other ones, right? If I did, they would all connect right there probably, right?
Yeah.
But I don't have to draw all of them, okay? So the centroid is going to be located where? 5, 5. That's where my centroid is, okay? So you only have to draw 1. Now, make sure you pick the correct one. For example, I'm going to do this in green. I would probably not want to do like this one because it's not going to be a very nice line to find the centroid off of, correct? Okay? You could have maybe done this one because his line is going to be probably a straight up and down line. But try when you're doing the centroid to find the line that is either a horizontal line or a vertical line to make it really nice to just count them, right? Okay, so we want to be able to do that. Got it? The 5, 5 is the centroid for that one. Good? All right, let's talk about orthocenter. Real quick, at the top of your paper, orthocenter, we're talking about altitudes. Again, I'm going to make you draw one of them for your test. So if we take a look at this triangle right here, this is something kind of fancy. B is like my little airplane, and we draw him straight down, and he's an altitude. Great? Okay. But let's say I have like this triangle going on, right? This green one, which is what kind?
Alright.
This is a,
You're talking about.
this is an obtuse triangle, because this is an obtuse angle, right? Okay. So like imagine like here's my airplane, and rather than him being in front of me, I'm like aiming like a radar gun back this direction at him. Does that make sense? Okay. So he's like outside of this triangle right here. And when I do the altitude there and I go straight down, what's going on? I mean, yeah, right. Like, but the altitude is not inside of the triangle like it was over here. Here's where my altitude is here, right? So, like when you're doing an altitude for an obtuse triangle, it's not going to be like in the triangle. It's going to be outside. What about for a right triangle?
It's gonna be the thing, isn't it?
Like if here's my airplane, where's my altitude?
Straight down.
It's literally this side of the triangle, correct? Like that's what my altitude would be, right? So when you have a right triangle versus an obtuse triangle versus an acute triangle, you might have like altitudes that are like kind of weird. Okay, good? All right, let's go to this, find the orthocenter. Find the orthocenter, which is from the altitude. Let's graph those points here. -2 is at 4, that dot. 4, 4, and 1, -2. Okay, I'm gonna connect my dots, and we'll see what we get. He's like an upside down triangle, but that's fine. Okay, when I do this, the one altitude that's really nice, that comes out really nice, you know which one comes out really nice? Can you identify which one comes out really nice? The bottom one's altitude, so like if I pretend he's an airplane, he's gonna connect back this way, right? Like that.
Right at.
That one comes out really nice, okay? This one doesn't, the other two are kind of maybe a little bit harder to do, right? Like, I don't know, that one maybe is there, and this one maybe is here, okay?
We have to find the
There's
altitudes for all of them.
there's no real formula or anything for finding the orthocenter, like the centroid was a 2/3, 1/3 thing. There's not really that special thing going on here, so we're just gonna eyeball it and try to figure out where this orthocenter is. 1, 2, you think? I'm gonna say that's probably pretty darn close. As long as you're pretty darn close, I'll take it. Okay, I'll take it. 1, 2. Does that sound good?
See?
So again, this is the type of thing that I'll make you do on your test. I'll give you these 4 triangles and I'll say draw one of these. So if you need to check, this is what a perpendicular bisector looks like. An angle bisector is splitting the angle in half. Medians, altitudes, and then if you were to draw all 3 of them like they did over here, it's the circumcenter, incenter, centroid, orthocenter. This is just kind of a summary of what all of them are. Concept summary. That's just all 4 of them together. Got it? Kind of like our sheet that we have already does. Got it? Okay, so on your homework, practice side, do 1 through 12. And I'm pretty sure each one of those are a centroid. Practice side, do 1 through 12, and 13 and 15. I'll give you one little sheet of graph paper for 13 and 15. 1 through 12 and 13, 15. On the back side, just do 1 through 6.
Yay.
So 1 through 12, 13 and 15. On skills practice, just do 1 through 6. Okay? This is really short. A really short assignment. Okay? 1 through 12 and 13, 15, and then 1 through 6 on skills. That's it. Okay? Good. You may end up with 0.5s as your answer, which is totally okay. That's fine. I will give you one little piece of scratch paper or of graph paper for your 13 and 15. Okay? All right. Goodbye, Carson. Except I can't get it to go away. There we go.